So now we will import MatPlotLib to see how we can visualize data in histograms, pie charts, and donut charts. This is the code we need to run to import MatPlotLib, and as it is usually abbreviated to PLT, that's what we will import MatPlotLib as in line 4. The first chart we will do using MatPlotLib is a donut chart. If you eliminate lines 27 to 29, that creates a small white circle. On top you have a pie chart. So we'll create a donut chart showing the number of participants of each personality type. There are 5 personality types, so the first 5 groups of code here are setting up subsets of data from the original data set based on each of the 5 personality types. The third line of each prints an optional numerical statement outside of the chart. Line 22 creates a list variable that stores the name of the 5 numerical variables created above. You could name it something other than pi_data if you wanted, but for simplicity's sake, we'll keep it as it is. Line 23 invents a name for another list variable that includes labels for the donut chart in the order that their corresponding values appear in the pi_data variable. Line 24 is the actual pie chart function. Within it, the variable name containing the numerical data comes first, followed by the labels function that we set equal to the list variable containing the chart labels, comma, then we can optionally include the colors function. If we don't use the color function, it will use the default colors. So if we stop there and then on line 31 say plt.show, it will print the pie chart, but because we're inserting a white circle in lines 27 to 29, it will look like a donut chart. So we hit run, and there it is. Now for histograms. Line 2 is required as you decide how many bins will best represent the distribution of your data. Line 4 is the histogram function, and we want to filter to just show the overall personality scores in the data set. So we put personality in the square parameter brackets followed by bins. We could finish the code there and enter the closing round brackets, but if we want to change the bin color, we type color. If we want to change the red's transparency, we type alpha. If we want a pattern fill for the bins, we type catch and set it to a number of these special characters on your keyboard, like asterisks that produces stars. Then so that shows, you need to set its color using edgeColor function and setting it to something other than the color of the bins. Then line 6 optionally creates the chart's title. Line 7 and 8 optionally labels the X and Y axis, and optionally you can adjust that size. Lines 11 and 12 optionally changes the background color. Lines 15 to 17 optionally changes the color of the numerical increments on the X and Y axis. Line 19 prints the chart to the screen. Another library with lots of charts is Seaboarn. It runs off of NumPy, MatPlotLib, Pandas, but since we imported these earlier, all that's left to import is the Seaborn library and abbreviate it to SNS. But before importing, make sure that you first install it. Once it is installed, then hit run to import it. The only chart from Seaborn we will learn today is the violin chart, which compares the distribution of 2 variables. We will compare the distribution of openness scores for the males and females in the data set. Hit run, and we see a steeper curve of females openness score than we do for males, whereby males seem to be closer to an even distribution.